Hey, so in this video I want to talk about namespaces again. Now I have introduced namespaces in Module 101, but I want to cover it in a bit more detail in this video. You can think of a namespace as a named or unnamed scope, which is used to organize identifiers, or in other words variable names, function names, class or struct names, and the names of enumerations, right? So it's a scope used to organize those identifiers and to prevent identifier name collisions. At the bottom of this slide we have a namespace declaration syntax used the namespace keyword. Remember when we declared a class or a struct, you'd actually have a class or a struct keyword followed by the identifier name. Well, here we have the namespace keyword followed by the namespace name, or in other words the name of that scope. It can also be unnamed, but we'll talk about that in more detail later. And unlike a class or a struct or enumeration, you do not end a namespace off with a semicolon, because this is not going to be instantiated. This is simply a scope that you can access by qualifying the identifier with the namespace name. And within the body of the namespace declaration, you are going to have your namespace members, or in other words identifiers, so your classes, functions, and so on. Okay, let's just move on to a quick example in Visual Studio. Okay, a quick example for you. I have this namespace called demo namespace, and it has these members that is within the scope of the namespace. I have a variable and I have this struct definition as well, struct entity. Struct entity has some member. And then I go to main. Here I can set the variable which is within the demo namespace to 5, so I can assign 5 to var, which again is right here in the demo namespace. So you do the demo namespace and the scope resolution operator followed by the name, so you qualify the name var. Here I do something similar with entity. The name entity is basically our custom type, so I qualify that entity by doing demo namespace again, scope resolution operator entity, and then I instantiate that struct, so I construct entity. Then I can do entity.member, and I can assign 55 to that member. Then I do this console output, so I qualify the var again, and then I can do entity.member to print that member out. Build and run that, and we get 5 and 55. Remember, var is set to 5, and the entity.member is set to 55 right here. Scrolling up, we have this namespace standard std. Now instead of doing this, if I comment this out, we'll get a few errors with console output and inline. Doing this is going to bring in all of the identifiers within the standard namespace within the global namespace, and you often don't want to do that. So what you can do instead is you can bring those names or identifiers into a local scope, in this case into the main function, and you can see those squigglies go away. What you can also do is something like this. We use this using keyword, then we qualify console output, so cout with the namespace, so in this case standard. So we do std : and cout, and of course we can do the same thing for inline, and that squiggly will go away. Build and run, and this works fine. Just undo all of that. And so what does this mean? Well, what we can do is we can do something like this. We can bring those names or identifiers within the scope into the scope of the main function by doing using namespace, demo namespace. Then we don't have to do the full qualification anymore. We can remove that. We can remove this right here and this right here as well. Build and run that, and that works fine. Now, of course, if you have two different namespaces, but within those you have some declaration with the same name, so a function declaration or a variable declaration or a class or something like that, and you include both of those into the same scope, such as within the main function or some other function, right, by doing using namespace and the namespace name for both of those, then of course you'll have that redefinition or name conflict error. So that is why it is often best not to do using namespace, especially not global to your file. It's often alright to do that at the top of a function, so local to a function. That is when you know you won't have some conflict, but in most cases it's best to use the fully qualified name. So you do the namespace name, the scope resolution operator, and then your identifier. Just undo a couple of times. And just like with the standard namespace, we can bring in a specific name or identifier, in this case entity, by fully qualifying it. So we qualify entity to the demo namespace. Demo namespace the scope resolution operator and the entity. Now where we instantiate entity, we don't have to qualify the entity type anymore. We can do that. But of course, if you try and remove this, or in other words, if you don't qualify var, then we'll get var is undefined, because that is within the scope, the demo namespace scope, and we haven't brought it into the local scope, so into the main scope. And the same thing over here, where we do the output is not going to know what this var is. If you try and build that, you'll get an error on line 18 and 25. Var is an undeclared identifier. And of course you can bring in var like this, and then you can remove those, and then you don't have to qualify it anymore. Build and run, and you can see that works fine. And in this way we only bring in what we are going to use. So again, a recap: when you do something like this using namespace std, you are going to bring everything in that namespace into scope, in this case right here into the scope of this file. Whereas if you do this sort of thing, you only bring in that single identifier or name into the scope. Currently we are bringing these two names into the scope of main. It's important not to confuse the global namespace with an unnamed namespace. It can get a bit confusing, but unnamed namespaces are very handy, so that is why I'm covering it here for you. We are familiar with the global namespace or the global scope, where identifier names have global scope. And of course, if you have two identical names or identifiers in the global scope, that will cause a conflict. And to avoid, you use local identifiers instead, so within functions and class or struct definitions and so on, or scoped enumerations. But you also have the option to use unnamed namespaces, in which case identifier names will have file scope. By placing related identifiers, so functions, classes, variables and so on, in an unnamed namespace, those identifiers can be reused in another file scope. Once again, this is just a summary for you, so let's just go and look at what this means in Visual Studio. Okay, back to our demo. We have this demo namespace with an int var within the scope of that demo namespace. And in main, I have the statement using demo namespace var, so that I can assign 5 to var in this way, and then I can print it out here as well. Let's do some global variables, so I have int var, and I set that to 33. Now remember, this is outside the scope of the demo namespace, and it's not local to any function or anything like that, so it is a global variable, so it's in the global namespace. Back in main, remember that I assign 5 to var, and I print var out. So you can think for a second what's going to happen if I build and run this. Build and run, and we get 5 and 55. And that's because we already have this local variable called var. If I want to print out this one, which is in the global namespace, remember the global namespace does not have a name, as I mentioned in a previous video. So we qualify var using the scope resolution operator, but it's not going to have a name. And in this way we can change the var from the demo namespace, but we can also access or change the var from the global namespace by qualifying it. Build and run that, and we get 22 and 55. Or if you remove this qualification, you should get 5 and 55. Now here's another problem for you. To make things even more confusing, let's say I introduce a local variable, also named var, and I initialize that to 33. Then I have this var right here, which is from the demo namespace. Build and run, and as you may have expected, we get an error. Int demo namespace var redefinition, you'll get some sort of redefinition error. Instead of doing this, I'm making this global to the local scope, the entire scope of main. I'm just going to remove that, and then I will qualify var, demo namespace, scope resolution operator var, and I set that to 5. And then we also have the global one. Okay, so we have the global namespace var, the one in the demo namespace, and we also have a local variable named var as well. So this line right here is going to print out the local one. Then we qualify the next one to the global namespace. Again, the global namespace does not have a name, so you're just going to do the scope resolution operator followed by the name. Whereas here we have a name, we have demo namespace followed by the scope resolution operator and then var. And then we also do entity.member. Let's actually just go and change some of these values to make sure we get the right ones as we would expect. Int var, this is the local one. Let's change that to 11. Next we do the global one. Now it's going to change this right here, int var. This could be anything. Let's just set that to 0 because we're going to change it right here to 22. And then demo namespace var, let's set that to 33. And then entity.member, we can set that maybe to 44. Build and run. And we get what we would expect, 11, 22, 33, and 44. And what's more, you can have multiple namespaces, so namespaces with different names, and all of them can have the same variable name var. And to access it each time, all you'll have to do is to qualify the name with the namespace, identifier, or name. So hopefully this was not too confusing. I'm just trying to show you that you can use the same name in different scopes and how you can access those names. Sometimes you can have conflicts, redefinition conflicts, and you can avoid that by using namespaces and by qualifying things properly. Okay, in this example I have the demo namespace again, but in this case I have void hello within the scope of that namespace, and I'm going to do cout hello within the function body, and I also have an enumeration within the scope of demo namespace called the eGame difficulty with the enumerators easy, normal, and hard. In the global namespace I have the eTerrain difficulty enumeration, which also has the enumerators easy, normal, and hard. Okay, now in the main function I want to instantiate the eGame difficulty enumeration. I call that difficulty, but you'll notice that I have to qualify eGame difficulty with the demo namespace because eGame difficulty is now defined within the demo namespace. And then right here we also have to choose hard. We cannot simply do hard like that. Okay, we'll get an error. Under that, that'll build fine. Now of course you can do something like this using namespace, demo namespace, and then you can remove the namespace part of the qualification. And then here I can simply do eGame difficulty, scope resolution operator, and hard to qualify the hard. And once more, if I build and run, this will work fine. If I remove this right here, the qualification for hard will get an error because eGame difficulty is unscoped and eTerrain difficulty is also unscoped, and that means we'll have a conflict with the enumerators. So if I build, hard is an ambiguous symbol. Okay, so it doesn't know which enumerator to use. Should it use the enumerator of eTerrain difficulty, which is global, or should it use the one in the eGame difficulty? Before C++11 we did not have scoped enumerations, so all of your enumerations were unscoped, meaning that your enumerators were basically available outside the scope where they were defined. So what you would do prior to C++11 is you would wrap your enumerations, your unscoped enumerations, within a namespace like this. But of course we now have scoped and unscoped enumerations. So for eTerrain difficulty, if I do enum class, so I make that a scoped enumeration, then we can do it in this way in main right here. And we won't get a conflict with the hard enumerator. We'll actually remove all of that code so we can focus on the function within the demo namespace. So I'll remove the enumerations for now. In the demo namespace, I declare and define the hello function, and then in main I invoke that function and I have to qualify it. Again, if I do not qualify it, it's not going to know about hello. Hello is wrapped within this scope now. So I'll have to go and qualify that. Build and run, and that prints out hello and end of program. So that works fine. Now following main, I'll actually copy and paste the namespace. And what you can do is, you can separate things out in this way. So now I only have the function prototype up here, and then I can go and define it down here. Okay, so again we have the prototype or the declaration up here, and we continue the demo namespace declaration down here. So what I can do is I can go and define that function down there. Build and run, and that works fine. For this next example, let's go and add a class to our project. So right click, add new item, and I'll start with the header file. I just want to create some generic class again, so I'll do entity.h. and I'll add that. I'll just do some basic class entity and void toString, and then I'll go and add a new item again, a CPP file, entity.cpp, and I'll add that. Okay, next I want to talk about unnamed namespaces. So I'll go back to main, and then I'll just go and clean up a bit. In the main.cpp file, let's say we have this hello function, so void hello, and it prints out hey. Then in entity.cpp, and let's say in some other files such as entity.cpp, I have a helper function, but this is also called hello. Now of course if I try and build and run this, so Ctrl F5 to build and run that, what's going to happen is we'll get an error. That hello function is already defined. So I have a linker error, multiply defined symbols found. I can always mark this function in the entity.cpp as static. I can go and define the entity toString function. Remember in the entity.h, we have a public function void toString. I include the header entity.h. Then I can use some helper function within the member functions of entity. In this case, just as an example, we have a hello helper function. So I call that hello in the toString function. Now remember in main.cpp I do void hello and I do cout hey, and then I call that in main. So in main I construct entity and then I do entity.toString, build and run that. And that looks fine. We get hey from the global function and hello from that helper function in entity.cpp. What you can do is you can also wrap those in a namespace. So instead of doing static, you can do a named or an unnamed namespace. In this example, I'm going to do a unnamed namespace. The scope of the identifiers that are within the unnamed namespace are going to be file scope basically, so they are going to be local to the file, similar to static functions for example. So we can do this, and in main.cpp we have void hello. Now this again is global, and so in entity.cpp, to avoid a conflict, we do this hello and wrap that within an unnamed namespace, build and run, and we get hey and hello printed out. So by using named or unnamed namespaces, you can reuse these identifiers. Let's say you have helper functions, for example, then you can reuse those identifiers in other files without getting any conflict. A quick summary for you before we move on to other examples. We've seen that we can access namespace members in three ways. Firstly, we can use the using directive. That is where we do using namespace, those two keywords, followed by the namespace name. That is going to bring everything in the namespace into scope. Now this may be used at the top of a .cpp file or inside a class or a function definition, but you want to avoid using directives in header files or .h files, and you want to use fully qualified names instead. As I've demonstrated in previous examples, the using directive can cause conflict or identifier name hiding, and that can be difficult to debug. So again, you want to avoid the using directive unless you know that you won't have any conflicts. Then you can also fully qualify the identifier, so you can do the namespace name, the scope resolution operator, and then the member. Then the using declaration is going to bring one identifier into scope. You do the using keyword followed by the namespace name, the scope resolution operator, and the member, or the identifier ending off with a semicolon. Next, I want to talk about namespace blocks. Now, a named namespace can be declared in multiple blocks across multiple files if you want. So across multiple files or in a single file. And the preprocessor is going to join all of those blocks and form a namespace containing all of the members declared in the blocks. Okay, I'm back in the example again in Visual Studio, so I'm not going to change anything. I still have this global function right here. I include entity.h, and in main I do hello, I construct entity, and I do entity.toString. But let's say in entity.h now, for some reason I want to define the toString function right here. So I'll go to the entity.cpp file, and we'll look at what we do in the body of the toString function of that entity class. We call this hello function, which is currently defined in an unnamed namespace. So let's keep that in mind, but for right now I'll go and delete this. And then I'll give this namespace a name. I'll go and copy this namespace block, this demo namespace block, go back to entity, and at the top here, so in the entity.h file, and just like we've seen in a previous example in the main.cpp file, where we separated out the declaration and the definition of this hello function right within the demo namespace, but in this case one of the blocks is in the entity.h file and the definition is in the entity.cpp file. Now this is one way that you can do it, and this is fine. Go and build and run and this will work fine now. We still get hey and hello printed out as before, but you can also, so we do void hello, and of course if you try and build and run now, I'll just build and you'll get an error, you'll get a conflict again. So instead of doing the entire namespace block as we've done it before, we can do void demo namespace. We qualify the hello function to the demo namespace. Remember that hello is not a member function. The toString right here is a member function, and that calls or makes use of the hello function, but that is declared and defined in the demo namespace. Okay, that is why we qualify it right here. And so for that reason, we qualify hello in the entity.cpp file to the demo namespace and not to the entity class. Build and run and that will work fine as well. Prints out hey and hello again. Now in entity.cpp, if you go and do using namespace demo namespace and you try and remove this right here, pull that, and as you may have expected, you'll get an error. So the point with this example is that even if you do using namespace at the top of your .cpp file, you will still have to go and qualify your namespace members like this right here, and that'll build fine. Yeah. We can also nest namespaces, and a few notes on that. The nested namespace has direct access to the members of its parent, but the parent namespace does not have direct access to the members of the nested namespace unless the nested namespace is declared as inline, as you can see in the example at the bottom of the slide. Okay, let's look at a quick example. Okay guys, we only have a couple of simple examples left for our namespaces, and in this next section I'll talk about nested namespaces. So this example here, we have a parent namespace and then we have this nested namespace. You can see this declaration of the nested namespace within the declaration of the parent namespace. And within the nested namespace we have an int var, which I initialize to 55. And then we have this hello function again, void hello, and I do console output hello. In main I now have to qualify the name, so I do parent namespace, scope resolution operator, nested namespace, scope resolution operator, and then hello. Build and run that and that'll print out hello. Now a few things to note here is that the parent namespace does not have access to the nested namespace's members. So for example, if I want to do a function in the parent namespace, something like this, then it's going to tell me var is undefined. I'll just do it like this. You can see that print var is within the parent namespace, scope, and it does not have access to the var which is in the nested namespace. Now if I go and reverse that, I'll just paste the print var function right here within the scope of the nested namespace, and of course that will have access to the var variable because it's within the same scope. Also, if I paste the var within the parent namespace, then the nested namespace will still have access to it. You can build that and that'll build fine. Now there's one more interesting thing I'd like to note here, and for that I'll take a few steps back. So we have int var within the nested namespace again, and then I have this print var function, and I'm trying to do cout var, and as I mentioned we'll get an error, so identify var as undefined. You can try and build that, again you'll get an error. Now what happens if I do this? I'm going to use the inline keyword followed by a namespace, the namespace keyword, then the nested namespace name, and within some nested namespace I can have a variable or some function, and you can see this function print var, which is part of the parent namespace, now all of a sudden has access to this var variable which is actually in the nested namespace. I'll just build that, and you can see we don't get a fail, this succeeded. And So in main, I'll just call that function print_var, qualify print_var with the parent namespace. Build and run that, and you can see that works fine. We get hello and 55. Alright, so what is the takeaway with this? Well, members of an inline namespace are going to be treated as members of the parent namespace. So in other words, members of this nested namespace, this nested inline namespace, is treated as members of the parent namespace. And actually, one final thing before we wrap up this video, we can use namespace aliases, or in other words, other names for our namespaces, typically shorter names, because namespace names are often going to be long because they have to be unique, and you don't want there to be a conflict. And it can become tedious if you have to type that name over and over again, such as here with parent namespace, for example. It would be nice if we could have a shorter name for that. So I mentioned you should not be using directives in header files, and that's an example of a case where it can be a bit tedious because you'll have to be typing the full name of the namespace everywhere you use it. Instead of doing that, we are going to create an alias, in this case n, that's much shorter. Now we can simply do n print_var, for example, build and run that, and you can see that works fine. Okay, so n is an alias for the parent namespace, or in other words, it's a different name for the parent namespace. And with that, that is going to wrap up this video on namespaces. I hope you found this section interesting, and I'll see you in the next video.